Hi everyone, welcome back. This is Raju from Smart AI Technologies. In this video, we are going to demonstrate a project called Instagram Fake Profile Detection using machine learning. So the website that you are seeing here is a complete web application that is built after doing so much of research over the multiple IEEE papers and then proposing our own methodology, then implementing our own methodology and building a project in the back with the back end and the front end together, and then forming this website where we have features like we can upload any new data set, basic information, pre-processing, EDA2, model data, test application, as well as the test Instagram ID. So here, if you feed only the Instagram ID itself, and if you click on the predict button, you can able to predict whether that Instagram ID is fake or real. So this is a sample of that front end, but we'll now discuss in depth about the things. Like first we'll discuss about what is mean by fake profiles and how they can be detected and what is the problem that we are facing, and how machine learning can solve that problem. Then we'll go back and discuss about each IEEE paper, and we'll discuss about what methodology they are using and how these papers are written, or what was the main idea behind these papers. And then we'll discuss what is the research gap that is there in this paper so that we can solve those problems. Then we'll propose our own methodology based on these three IEEE papers existing system. So then we'll go further and we'll implement it as a code that you can see here. So we'll be making the complete codes, and after that we'll save our best model. Then we'll create front end and back end. We write Python codes as you can see like this. Okay, we'll be writing complete Python codes, HTML and CSS. Even for the backend we are using Flask, so we write all of them together and we build a good looking web application. So this will contain the long process. Now we'll move for one step, and we'll first discuss what is mean by fake profiles first of all, and then problem caused by the fake profiles. The third one, methods to overcome the fake profile issue, and how machine learning can be very helpful tool to overcome this. Okay, and then steps, a ML based fake profile detection process. What are the steps that we normally pass through, and challenges detecting fake profiles using ML also, and future ML based fake profile detection. All these topics we'll discuss one by one. Then we'll discuss about each IEEE paper. That is, we have around three IEEE papers. We'll discuss the existing system, what they proposed. Okay, then the first thing is, what is fake profile? Faking or fake names are aliases, and stolen or generated profile pictures, and fake locations or biological details, and bot-like behavior such as automated response and bulk messaging. The first one is fake names. A person who keeps someone's name, not his real name, faking some other person, or creating some other person's profile photo. Just like other, they will create and edit and create their photo, and they will copycat it. And fake locations, to that profile the address of someone will be used, so the misinformation of that address will be used. So that is also faking. Either they can fake the name, a boy keep a girl name, that is faking. Okay, names. And stolen or generated profile picture, a person keeping some XYZ name but some other person's profile image. And fake locations, a person, a ABCD person keeps some other person's exact location which is really there, but it is not the person's location, XYZ person's location. It will be different persons. And bot like behavior, nothing but whatever the communication happens from that profile will be unique almost. Maybe its responses or the requests, okay, almost be same, similar. And what are the problems caused by the fake profiles? You may heard about, there are so many, there are plenty of issues regarding these fake profiles and keeping creating a profile, Instagram profile on someone's name, and they are misusing that. All these things you may be looking into the present news and like that. There are so many things that comes to our mind when we discuss about the problems caused by the fake profile. So let us discuss about it. The first one is cyber security threats. What type of threats it will cause? Spreading malware or phishing links. Yes, for example, there is a fake profile in the name of some XYZ company. Okay, they will fake the company name as well as logo or like that, and then they will share you the links. You may feel it as an authenticated link, then you will click on it, gone. They can do the phishing attack or some other type of attacks. And hacking, again, hacking and unauthorized access of personal data. So they can do any type of attack because you will be accepting their request by clicking on the links. So all the information they need, they will fetch it. So this is the one stuff. And misinformation. Okay, now misinformation is again the same stuff. It means, for example, creating insta page based on some XYZ political party and leaving so many posts, okay, that are against that party. So this is one kind. Again, it can happen personally also. So like this, first among them is manipulating public opinions through false news or propaganda. Again, as I mentioned, with help of that political party, XYZ political party, and influencing the elections of public discussed by impersonating trusted individuals. Yeah, this one is impersonating. It means some trusted person name. On some trusted person's name, they will create a fake ID and they will try to influence on the elections. And some frauds and scams can happen. Among them is financial frauds like identity theft, okay, romance scams or phishing attacks again, and brand and reputation damage can be happen. For example, some fake account or some XYZ application or services is being created to destroy its name, to damage its reputation. These things can happen. Psychological impact, yeah. So when it comes to harassment and bullying or emotional manipulation, they can be caused because by this fake account, because let us say a new fake account is created on someone's name, okay, and that person, when he sees there is an account on his name and his information, his images are there in that account, how you will feel it? You will feel very bad. That's what harassment, bullying and emotional manipulations will happen to that guy. And user trust erosions. So when like these things will happen, always user will try to think twice whether we should use that platform, maybe Instagram, whether we can use it or not. Like there will be erosion in trust, okay. They will try to set back, okay, sometimes creating or using its new services or creating any new profiles are like that. People will try to fear, okay, whether to use or not. They will lose the trust over the technologies because of like these fraudsters. Methods to overcome the fake profile. What are different methods are there? First of all, one is user based verification system. So just like blue check marks and 2 to 3 layer verifications, maybe OTP, maybe anyway, OTP is already available in all the possible services, especially in Instagram. So if you need to log in, you need like login you can do in the same system at first. But if you are doing in a system which is not yours or unauthenticated, even the OTP verification need to be done. Okay, there is an option, and you can improvise this methodology by adding few more checks, just like blue check marks, reporting and blocking the suspicious profiles. Whoever feels there is a suspicious profile that is messaging them, that feels, for example, there is a person B and there is another fake profile for on that profile B, sorry, on person B, but it was not his. It means that is a fake profile for B. So B can report and he can ask for the blocking from the Instagram, like that. And automated rule based, and there should be a rule based process, just like suspicious IP addresses, unusual patterns like rapid friend requests, unlimited friend requests are being sent just after creating an account. Okay. Inconsistent personal details, and personal details will be random. They won't follow any pattern. The name, the details, the address, they don't match. In that case, you can just do automated rule based. You can keep a rule, and over that rule you can just limit it. Final comes machine learning. So in the machine learning, you can take all the parameters related to that profile. Then you can make data out of it. Then you train machine learning models, and then tomorrow, whenever a first profile will be created, and it should be monitored continuously, and that ML model will monitor. It will monitor. Okay, if it finds something gone wrong in that uh, Instagram profile, it will understand whether it's fake or not at some extent, and it can automatically block, because MLs or deep learnings, they will be having a high accuracy than the rule based, better than the rule based. Actually, machine learning models or deep learning models, they are lot better than the rule based, because these can take a decision based on any n number of features, not just like in a rule based where it will consider 2 to 3 conditions. Okay, it can take any number of conditions to say whether the particular profile is fake or real. Okay, then if machine learning can solve this problem in the better way, then how it can solve it? So we will train our model based on so many features. Let's say profile creation date, friends connection ratio, activity pattern, content analysis, image analysis, whether he's having a profile photo, how is that, and classification algorithms. When we have so much of data in our data set, we have so much of extra data also. You can see here profile pic is available or not, nums length of username, okay, full name words, and then comes length of full name, okay, whether name is equal to username, or description length, what is that, external URL is available, whether it's a private account or public, how many posts it is having, how many followers that account is having, how many people follows them. So based on that, whether it is fake or not, we can able to detect. And classification algorithms, there are so many machine learning algorithms, like decision tree and random forest, support vector machine, naive bias, and you can even go for neural networks also. And if you are looking for NLP models, you can even do sentimental analysis over the data or detail, and then you can decide. Even image recognition this also can be one of the most important technique to overcome the problem. Mainly this will be suitable only to take a decision based on the profile picture, whether the profile picture is fake or real. So here we already made a one video where we can able to detect deep fake faces. So if you can visit our YouTube channel, and there you will see the recent video. Okay, you will see a deep fake detection using deep learning model. So that this type of problem is being solved there. Which image is deep fake or which image is real, that can be detected with the help of the deepfake technologies. And also one other type of technique is that you can just take this image, okay, then compare with the database whether the similar or same image is already available in the database. If it is available, then why to have two profiles for the same person? This is a another way to say, if there is a fake profile, you can stop that. Okay, you can block that using that particular profile picture. Okay, now we discussed uh, how we are using, what we are using in ML. But now what is the process that whenever you work with the ML or these projects, what will be the process, say methodologies? Okay, normally, so we first take up the data pre-processing, then we go for feature extraction, model training, model validation, real-time monitoring what is happening there, and continuous learning will be there. When the data increases, that data will become again feed for our machine learning models. So our machine learning models will always be becoming better. Challenges in detecting the fake profile in ML. First is aviation techniques. It means the fraudsters always they will constantly change their tactics. They will not follow only one way, because even though our ML models, uh, we build it, we train it, it is bit it will take little bit delay to adapt the new changes in the data, so that may be misused by the like attackers or hackers. And this ML based, because whenever we are speaking about ML needs a data. So ML needs a data, this data should be about user. So if you are building a ML, you are fetching a user data, so that may lead to concern about the user privacy, because no user want their data to be used, not even for analysis also. And scalability is one of the problem, and imbalanced data set, because in Instagram maybe there is 0.1 to like that very minimal number of fake accounts will be there, but real accounts will be very high. In that case, you will having a problem of imbalanced data to train any model. So in that case, your models will try to bend towards the class which is having the more data, so that will also cause a problem. So again, what are the next level ML models that we can try in the future, or you can improvise it? Is reinforcement learning or deep neural networks, and multimodal detection you can do based on the behavioral features of that, and emotional you can extract the emotion of the description of that fake profile or whatever the profile it is. You can extract the emotion and understand. And the inter platform collaboration is also one of the way to do it. So till now we discussed about the importance of all this stuff. Now our next step will be go through the papers one by one. Okay, we need to do R&D over this paper, and we need to get information what these papers are speaking about, what methodology they are using, what they already implemented, and what is the research gap. So that we need to fill, so that we get better result than the existing paper. So if the first paper is fake profile detection on social networking website, a comprehensive review. So this paper, it's 2020 paper, and any paper you take, first you need to understand their methodology and materials, what methodology they are following. So if this is a review paper, almost review papers will be like they will go through multiple research papers. They will collect what is there in those papers instead of they defining their own methodology, because as a review paper it will review the old IEEE papers. So we made it as a point. Okay, actually material methodology, it will start from dataset collection, what dataset collection they did and what features they extracted, and it will again be okay. uh, Finally, okay, till here existing research on fake profile detection, and yeah, all these things will be there. Now we have made these things as an point and very simpler. Here you see, in the proposed system of this particular paper, when it comes to dataset collection, they because that was in a review paper, they are saying that among so many papers, they were using the dataset, multiple articles. They collected multiple articles. Maybe it is IEEE Explore or Springer Link, okay, Science Direct or ACM Digital Library. Okay, and the similar keywords are like fake profile, spammers, unauthorized users. These things are being used as a labels in their different articles. Okay, and all the articles actually were from reputed journals itself. And when it comes to feature set or fake account detection, there are different views from different research papers. In this part, first IEEE paper, in their review they are saying some paper uses information like username, biography, profile photo, header photo, theme color, birth date and location, whereas account activity like number of tweets, following count, followers count, retweets, likes and mentions, and content related information such as hashtag, links, number of replies, listed counts and sender informations. So these are the features used by the summarizing all the previous papers that being used in first IEEE paper. And what are different machine learning models are being used? Mainly random forest decision tree, support vector machine, logistic regression, gradient boosting, navy Bayes. Then comes deep learning models, CNNs, RNNs as well as LSTMs. These things are being used in the first paper. Now, if we move to the next paper, that is fake profile identification in social network using machine learning and NLP. So what this paper is presenting, okay, if here you can see, you need to check the implementation, what are all the things they implemented and what are all the features they used. You can see the feature explanations. Okay, what does each feature, nothing but we are almost going with exactly like this similar data set. Okay, so we can directly compare this paper with our paper, and almost we are also having the same number same features as an input in our data set. And yeah, so we're gonna see what this paper is doing, okay, with step by step points. The first one is dataset collection. They used a dataset collection of 556 entries, okay, and they have a second dataset with 776 entries with some manually combined data. It means they manually extracted few more data and they added it. And they splitted the data for 4/5 for training, 1/5 for testing. And cross validation, when they do, they are getting validation score of 91, and for dataset 2 they are getting 92.9. But here, as I mentioned, direct comparison, it means I am using the same dataset what they are using. I should get better result than this paper, then only it will be valid. So let us show you. 96, 95, 97, like that you will be getting always. But one more model. Okay, here you see logistic regression. What is that? It is around 97%. Accuracy, you see, 97.4025. Okay, log loss, it is very low. Again, you see, we have implemented multiple models. It is not one or two model. We have implemented around 6 to 8 different models, so we are getting far better result. So here you can see SVC support vector model. So that is also giving around 97% of accuracy. F1 score is very best. It is 97, 98. Okay, compared to other models. We have implemented multiple models. Anyway, I will be discussing about these different models and different techniques, what they are giving, what we are trying. Okay, why we are adding so many different models and different notebooks. We'll discuss that. But to be very direct, because this paper and my paper, like my work, is using the same data set, so direct comparison is fine. It means we can directly compare what is their accuracy and what is our accuracy. Based on that, you take the decision. So their accuracy stopped at 91, 92. We move to 197, 98. Average 97. Sometimes it can reach to 100 also. And what are all the classification algorithm this paper is speaking about? Random forest classifier, gradient boosting, and logistic regression, as well as Gaussian naive Bayes. These four models this particular paper is using. So if you compare this with our work, we are using more than this. We are doing like logistic regression, random forest, XGBoost, light BGM, ADA boost, cat boost, and many more. Different models are being used. And one more thing, to keep it very simple, we have hybrid model with a combination of all the above models, whatever I mentioned till now, 6 models. Finally, we build our own hybrid model that you can see here. The last one will be hybrid of all of them. This model we hybridized, we have built hybrid model that is a hybrid of random forest, logistic regression, support vector classifier, kn neighbors, and xgboost classifier, add a boost, and let bgm. So we have built so many, first of all we have built so many models, then we have built hybrid of them, a hybrid model of them. So that also it's almost 91-90%. But whereas our SVC and logistic regression themselves are giving more than 97% of accuracy. And finally they have gone with random forest because for them random forest was in a little bit good accuracies. So this paper particularly concentrated on random forest because that was the model which gave them better result, that is 91. And finally they are mentioning few more results here. They say F1 score 93 accuracy, as well as the 95 and 95 for dataset 2. But above they mention something else, it's fine. So they are getting more than 95, nearly 95 they are getting. This is their maximum, this is their maximum value, 95 is their maximum value. And they are comparing with the existing system. They done a research. Before them there were papers, those papers were having 84%, 92%, and 90%, and this paper is having 95%. But what about ours? Ours is actually more than 97. It is actually nearly 98, 99, but when you take average of them it is becoming 97. Actually it is more than 98 and 99 nearly. And then comes the paper 3, which is fake profile identification using machine learning, which is 2022 paper. And when you go through this paper you can able to see proposed work. So this proposed work contains all the information, what they are using, what are the features they are using, okay, how much accuracies they are getting, how much loss they are getting. So they are making a table out of it. Again they are at most they are trying to get 92%. Okay, they are not going behind that. They are getting around at maximum they are getting 95. Again this paper is stopping at 95 itself. Whatever paper that we are observing till now they are almost touching 95. Okay, they are not going above that. And when we talk about the paper 3, what methodology they are using to get a 95% accuracy? First one is what are the steps they followed. One is they collected dataset, pre-processed it, validated the information if there is any false information or like that. Then they done grid search to get a better hyperparameters, and they even gone with random forest again. And okay, these papers are using random forest itself a lot, but reality is that if they used SVC or tuned logistic regression, they could have got better result, and even they could have improved their pre-processing techniques, analysis techniques, and so on, so that they would have got the result that we are getting now. The data set, what are the features are there in the data set? Profile pic, followers, and how many people following, post, description length, almost same as our data set. These are all the features about the any profile, any Instagram profile. And the data split, again they are gone with 80-20. And what are all the pre-processing techniques are being done in this paper? None value. And if there are any object data nothing, but if there are any columns which is having alphabetical data, okay, that need to be converted into numerical. All those things are being done here. And for tuning they go on with grid search, and then they built the random forest algorithm. And only one model, these papers are going with only one model. So in our case we are going with plenty of models, and finally we are going with the hybrid of those models, hybridized ML models. And evolution matrix, again it is confusion matrix they are using to generate classification report parameters, precision score, recall score, and accuracy. They are even okay. This paper says sensitivity, that is recall sensitivity is maximum 96, but when it comes to accuracy it is around 94 itself. They are not going above 94. For every paper we have written a conclusion what these papers are finally highlighting. These papers are highlighting that using the gradient using grid search they can get a better hyperparameter, and if they go with the random forest they are getting a better result. But then next comes our research, our proposed methodology, what we want to try more, what we are adding more, how we are getting better result. So let us say dataset collection. Actually till now whatever the datasets you saw, there were few values are missing. In our case, let us see from here to here these many columns are being used. I can show you that dataset. Okay, profile pic, length of username, full name, how many words are there. Okay, length of full name and username, and description length, external UR, private or public, post, follows. So there are so many stuff. Okay, now dataset splitting you can do in any ratio. Normally 80-20 is fine. You can go for 75-25. You can go for 90-10. So if you want more data for training, better go for 90-10 also. And when it comes to data pre-processing, so here we have done so many stuff. I can show you here with by running this web application. What is basic information pre-processing? What are all the things done? EDA, okay, EDA data 2. What is that? Different models we trained, how they are working, and what results we are getting. Finally, how we can test that application, and how can we test it on Instagram ID. You can just paste the Instagram ID, you'll get the result. So here that's why okay, so first when we are doing data pre-processing, we normally try to fill up if there is any null value with the mean, median, or mode accordingly. So for example, how and where is it in our work is, this is a home page of our web application that you see. Okay, and here is a link to use our technology. You can upload the data set. So this will be our data set, and when you click on basic info, you will be able to see this basic information about our data set. It means this is head, a few columns are being plotted, and then you see total shape, 576 columns are there, 576 rows are there, 12 columns are there. And then you are gonna get the description. Okay, the description of each and every column. What does the description contain, and what is its importance? Is that, for example, say length of the username. So the length of the username, total number of words divided by total length of username. That's part. When you take, if it says maximum 0.92 nothing, but this is the maximum length 92%. This is the maximum length of that number nums divided by length of username. And then okay, better than that we'll take full name words, we'll take, then you will understand better. Let us say there is some full name for that Instagram ID. Now here this column, when you see 12, it means the maximum words, any full name of Instagram ID is 12. 75% of Instagram IDs data are having only 2 words as a full name, and 50% of them are having only one. 25% of them again having almost equal to 1. Okay, this is a way to analyze. And the average 1.46 full name words are almost 1.46 average. All Instagram IDs are having this one. Like that you need to analyze each and every column, you'll understand. And here you need to do one more analysis, that is outlier detections. All these things you may feel new because I can't explain in detail every step and technique here. You can directly approach us, you can just call to us, or you can just WhatsApp us. We'll be linking our mobile number below. will be helping you. So what are all the things, how to analyze these things better way, and how this gonna improve our result, that you should keep in our mind. And based on only this information, you will decide so many things, okay, how to do, what not to do, okay. And by doing which technique can improve our accuracies can be decided based on this stuff, these stuffs. And then data transformations, if needed, we'll do it. And mainly outlier detection, these things I will tell you now. Okay, so when it comes to outlier detection, for example, here we are doing it. Let me check it. Here Rashid, this code is for outlier detection. Okay, so outlier detection we are doing, I will explain each and every step, okay, again in detail. First I'm trying to show you what are all methodologies we are proposing, okay. I will explain each step. And then under feature selection, it is correlation matrix, lasso regression, wrapper. And in model building, we are going with multiple models, logistic regression, support vector machine, random forest, boosting algorithms. Now we'll discuss each methodology one by one in detail. What are they and how we done it in our codes. First one is dataset collection. As I mentioned, we are collecting a dataset with all these features. And then after collecting the dataset, what you need to do, you need to split the dataset. And then in the pre-processing part, these are the sequential steps you need to do. So in the next process, in pre-processing, normally we go with missing value detection that we did here. So to do the missing value detection, you need to check it. So that's why if you click on pre-processing data, you can able to see, first of all, we'll check, is there any null values? Is there any problem in our data set? Okay, normally we don't have any problems. So if we handle that also, it won't make much change because there are no problems, there are no null values. And after pre-processing, we'll update our data set. So in our code, we are handling the null values and extra values. And then outlier detection. What is this outlier detection and why it is needed? For example, let me now is here. For example, uh, in our case, let us take number of words for the full name of the profile. So let's say minimum 2 to 3 words are being used, but there were some IDs which uses 20 words, 24 words. So in that case, these IDs will be very rare, but they will be there in our data set. So by having like these which are very out of box, okay, so in that case we need to detect them and we need to remove them. But because you need to be around the average, that's what the box plot is in our graph. If you see, we normally draw like this box plot, and there will be line going on, there will be a dot here. It means what it says, if x-axis or y-axis is here, and let us say this graph is all about number of words in the full name. So here it is average 2, 3, 4, maybe it is till 6 or 7, let us say, okay. Now if it goes below this, if it goes above this, they are outliers. Their use is not much. It means they are disturbing our model. Their values will be very, the number of those values will be very less. They will be out of the average data. Okay, we call them outliers. So detecting outliers and removing them is one of the most important step, because when you remove unwanted, the concentration for our model will increase over the real data, the average data. So then the model performance will anyway increase. So that's why what we do, we select few columns Okay, based on them we're gonna do outlier detection. And how we decided to remove only outliers of these columns. If you approach us, we will discuss in depth those things also. Why only these columns, why we didn't go for other columns. And now you can see this is before the outlier detection. You see this one, length on a full name like this. It means this is actually box plot which just looks like a line. Actually it should be a block spot. So there are so many outliers here, plenty of outliers. So now when I detect and we remove it, okay, you can see here outliers are being removed. The average is almost, it is only the box plot. Whereas when you see here the followers is also same again. You get followers which is having more outliers. Okay, it just looks like a line and more outliers are there. So this also can be handled, and when we remove, you can see the box plot is visible. Only few outliers we can keep. Actually you can give a range to uh, detect the outliers, in which range it should be there, whether it should be 25%, 75%, whether it should be 15%, 85%, or it should be 5%, 95%. You can give any range, and based on that you can filter out the outliers. So those outliers detection and handling that outlier detection is one of the most important technique we need to do. And then comes the most important technique, that is feature selection. So here we can normally use multiple techniques like correlation oriented, and there are techniques like lasso regularization technique, and then goes for wrapper methods. So different techniques are there. Then how we are deciding only for feature selection, these many are there. How we are deciding is, first we'll build them separately one by one. First we build a lasso, then we'll see accuracies. Accuracies are 89, 92 are like that only. Okay, for logistic regression are like that. If you see the accuracies, okay, 91, 92, 89, such a values are coming. Then we build a model based on the another technique. So these things will give us the importance of the features, lasso as well as wrapper techniques. For example, this you see, once I apply the wrapper technique, it says what is their importance, how much they are impactful. So which are the most important features that gonna impact, whether you're gonna take all the features, whether you're gonna take most important features, how you decide. So this is the way. So here you can print like this also, it means you can see here. So this is lasso one, and now let me try and show you. For example, this says, okay, this feature pic profile says 22. It means the fake profile or not, it depends on 22% on this parameter. Whereas nums divided by length of username, which will be very high. Actually this is very high, more than 50% or like that is there, more than 60%, which is very impactful feature. And then comes these things, these two are most important. 8% and 9% are there. 7, this is one of them, and 28%. So like these features, the remaining features you can neglect them. Why we need to neglect, I will tell you. For example, what is the meaning of feature selection, I will tell you. Why we need to select like these features based on lasso or wrapping technique, and how they are improving the accuracy. First you understand, you go for buying a car. Okay, you take a brand. Now you have two cars of the same brand. Now there is another car which is a different brand. Now when you will be seeing about the pricing of these cars, first you will see different brands, randomly different brands. Okay, then you will see much price difference. One will be 15 lakh, another will be 28, another will be 32 lakh, 52 lakh. There is a lot of difference. Only once you get the brand, then you go for color changes, colors. But by changing the color of car or different color car, is the price gonna change? No, it doesn't. Okay, during your selection process, did you first gone with the color of the car? No, first you were deciding based on its features, how powerful its engine is, okay, and how average it will give, and what are the technologies are being used in them, and how many seats are available. So they are most important features. So color was not the most important feature. You didn't consider color in the first place. After you selecting the brand, you may go for coloring in the same brand. It means you can neglect the color to decide the best car. So color of a car will not be a parameter to select the best car, like that. So these are not much probabilistic values, sorry, these are not much probability values over our data. So that's why we don't take them. We take only what features are more impactful. So that's why feature selection is, once you do the feature selection, different feature selections we done separately, and they were giving different accuracies, and we built a multiple model. So here, after feature selection, you see here, I'm gonna select only limited features. I'm not selecting all 12 features. I'm going for limited, which are very useful and very important. And how I'm saying very important, because I have applied lasso and wrapping technique, and I got to know what features are very important better, and that only I'm deciding. Then comes the model buildings. What different type of models I'm building? Random forest classifier, okay, and then go for logistic regression. Then we build support vector classifier. Then we build k nearest neighbor. Then we build xgboost classifier, and then add a boost classifier. Then comes cat boost, and then comes light bgm. After that, we didn't stop here. We used all of these models, and we built a hybrid model, a new model with a combination of these models. And then when we train that hybrid model, we are even getting a good accuracy itself. It is 1993 F1 score, and average accuracy is 92%. So each and every models are giving their own accuracies, their own classification report. We have done so many combinations, okay, we've done so many codes. So each code is having its own uniqueness. That's why you can feel the accuracy difference. Here initially it was 9091, and after that we are getting 9390 here itself. So we have improved the result. Now we'll check with our user interface how it is and how it gonna work. So this user interface is built using HTML and CSS that you can see here, okay. So many codes that we done. This is based on HTML CSS. In the backend we are using Flask for that, and we built this complete web application. And this web application initially contains home page, okay, and then you will be having redirectors, okay. Either you can click on this home page, or you can click on detection to directly go for that uploading stuff, or and this is our logo that we are added. And if you click on this Instagram profile detection using this, you can able to choose any data set, any like this data set. And if you click on a basic information, you can able to get complete basic information. All these things we done in a notebook as well as in a website. So in website you can showcase all the stuffs clearly by clicking on a button. Otherwise, if you want to show all of these things in a Jupyter notebook, you can show it from here. And then comes the next thing, that is pre-processing the data. When you click on the pre-processing data, as I mentioned, here first we'll understand is there any null values. If there are any null values, we'll handle it using mean, median, or mode techniques. And then EDA data. In EDA data, we are gonna plot few graphs to analyze what is happening in with our data sets or input output columns. First one is distribution curves. So it will give us the information like how the data is being distributed, how many profiles are having nums divided by length username. It means 300 profiles are having around 0.0 to 0.1 nums divided by length username. Our full name words, if you take, there are around more than 250 profiles which are having one full name word, whereas around 200 profiles or less than 200 profiles are having two words for their full name. So like this, these are all distribution curves that you can see, and these are for columns that are numerical, and the below one is for object type columns. If you see profile pic, actually profile pics, like around we have more than around 500 profiles. Among them 400 are having a profile picture, whereas around more than 150 are below 200, around 170 you can say, these profiles are having no profile picture. And when you see another parameter, the name of the profile as well as the username of the Instagram profile, they both are same only for around 0 to 20 or 30 profiles. Other than that, the name and the username both are entirely different. When you see external URLs, actually less accounts are having less profiles are having external URLs. Actually more than 500 are having no external URLs. Same with the private one or less, actually more accounts are actually public. And this one is a correlation heat map. So here what will happen is you will try to get a correlation value between the two variables. For example, let us say fake as well as follows. If it says 0.22, what does that mean? If follows are increasing, there is a 22% of chance that it is a fake, or reverse, it is not fake, like that. So minus always indicates the reverse. If it is 25%, it will to post. If there are more number of posts, it will move negative to the fake. It means if 1 equal to fake, it will move towards a 0. It means no fake. More number of posts, no fake. Okay, more number of follows, no fake. Whereas this you see username 59% positive. Okay, fake. What 59%? It means if the username length whenever it is increasing, 59% chance that it is going towards the fake. Again, full name, number of words in full name, if that is increasing, 25% positive. If numbers are increasing full name words, it means there is a chance of fake, in 25% chance that it is a fake. So after doing EDA 1, we can go for EDA data 2. Here also few graphs will be plotted. Okay, violin plot is being plotted, but all the data of this actually concentrate between 0 to 0.1 or 2. That's why it feels like it is at the low level. And for one, that is for one, almost it ranges from 0 to 1.50, but the average is again the average is 0 here. And scatter plots, so whatever the followers are the scatter plot we did. Okay, how the values are there, each and every follower data is being plotted here. And line plot also is being done, description length and nums length. All these we can say they are all rel plots, the relation plots, how follows and followers are related. So when they meet, it is all about the relation. Okay, how the data is being changing with respect to another variable. Here how user length length username as well as the description length, how they are correlated. You can see this is a correlation itself. So you can say that, for example, what does this green line 0, for 0 when length username increases, the 0 positivity of 0 is more. that length will always increasing, okay, like that. This is bringing a direct relation to that. All these graphs we call them as a rel plot or relational plots. How followers and post will be depend upon, again, as a graph. After all these basic visualization, we go and build a different type of models. And here only three we displayed. We could have displayed all the remaining whatever you saw in the uh, Jupyter notebook, but here we have tried to display only three of them. You can display any number of models here. We can display all of them whatever we done in Jupyter notebook, but for now we are going only with three models. So you can see all the details. When you click on the train model, the three models are being trained, and even you can add all of them here. Okay, all the classification report you are getting, accuracy you are getting for different models. And you can test that application even. So let's say profile picture is not available. Okay, user link name. You can just I will just add random values, okay, for testing purpose. And num username one, and I can say it is one G11, private account 01, number of posts 0, number of followers 0. So there is a high chance like it will be a fake, because I added number of followers 0, number of followers 0. So let me take this as 100, and number of followers it will be 120, and number of posts, posted 24 posts, and private account yes, and external URLs 0, and description length, let us say keys and 32 words, and name is code number no, no, full name length is having 2 words, and full name words 2, username length 1, profile picture yes. If I predict, I'll be getting these details. Okay, let me number post 24 and description length 12. You can add those details randomly. Okay, you can add any number of full name words. How many are there? Let us take 1. Okay, you can add, for example, I will add randomly. Okay, so like this you can go on adding all those details one by one, and when we feed based on that, we'll be getting whether it is that ID is fake or real. You can try few more. Okay, you can add, okay, how many posts are there, how many followers are there, randomly you can add. And if you want to test, you can even take from that database for testing purpose, and you can predict on that. So this is one way, and there is another way to do it, that is test Instagram ID. Here you can test. Actually we have reached the limitation for testing it. We have tested it on all these stuff. So here what will happen is automatically it will fetch, okay, it will fetch automatically all the details of your Instagram ID. For example, I could have shown you the demonstration of it. We have reached the limitation, otherwise I would have shown that also. Here just you enter the Instagram ID, then click on the predict. It will fetch all those details automatically. For that I have a code, even I will show that code to you. Automatical detector. So once if there we are removing this for safety purpose. Okay, so it will try to extract all the information about that profile. Okay, and then I will take all of this and I will make it as a data frame, and I will give it to the model, because this is my trained model, and I will feed to my model and get the prediction done. Okay, so even I tested on all these things, okay, all those labels. So this is complete applications. This is a complete application that contains from basic information about a data set to completely building a best model compared to any other existing system. It is not a simple Python code that is being written. It is complete research and development. You can take this and you can publish a paper because you are getting good result on the same data set, and you can prove it. Whatever you are doing, you are doing right. So you can prove it. So when you can prove it with a number, no one can question you. If you write IEEE paper or some other paper, when you have good number in your hand, no one can question you. So those papers will be published easily compared to these papers, because you have proof, you have numbers, you have coded everything, and you are presenting technically everything. Okay, so each and every parameters, accuracy, loss, classification, report parameters, maybe precision, recall, F1 support. Yeah, this was all about this project, and if you need complete project, please approach us. You can just call us, or you can just message through our WhatsApp number, and we'll be almost available, and you can just WhatsApp us. 100% we will respond to you, and we will be able to give you complete what is the support if you are building any research, or if you're building a project, or if you are doing for your like to improve your what do you say, CV. So if you want to improve your CV with some good project, some researchable project, so you can even add this project to that list, so it will impress the interviewer. So yeah, it will be positive side for you always. Yeah, this was all about the project, and if you need any support, please contact us. And one more thing is, with Smarty Technologies, as I mentioned earlier, we provide complete supports to mainly to students, researchers, as well as some startups. If you are working on like these projects, we'll be helping you with the technical stuffs and implementations. Okay, thank you very much. Don't forget to click on subscribe and bell button. Thank you.